Give me a lever long enough and I can lift the world. Those were the words of Archimedes. 2,000 years ago, his theories formed the foundations of speed reducer technology, a crucial component in countless industries, one of which is aeronautics. You may not realize it when you board an airplane, but speed reducers can be used everywhere. From the actuators that control and stabilize the aircraft, to the mechanical systems which deploy the landing gear. And when we talk about the engine, the accessory gearbox is filled with speed reducers. This technology is becoming so important that next generation gas turbines are implementing them in the core of the engine. But what is a speed reducer? A speed reducer is a sophisticated gearbox, also known as a drive, which is placed in between the motor and output and transforms speed into strength. In other words, it is the heart of a mechanical system. And the last time there was a fundamental update in this technology, we were able to send people to the moon. Today, that technology that was used in that lunar buggy is seen in the world around us. This shows you the potential of such an innovation. However, it also shows you that speed reducer technology hasn't changed for over half a century, meaning that today's most high-tech mechanical applications are forced to run on the heart of a 50-year-old. And that's where we come in. We at IM Systems reinvented the speed reducer because we use friction instead of gear teeth to transmit torque. This means that we can double the torque density, meaning that we can reduce the size and weight of our drive by half. And since we don't have to take gear teeth integration into account, we can produce our drive for a quarter of the cost. But most importantly, our drive can run lubrication-free, drastically decreasing the maintenance. If you apply these advantages to the aeronautic industry, we'll be able to make lighter, more aerodynamic aircraft that require less maintenance. And we could become a key player in a market that has a size of $5.5 billion. But see, this is just aerospace. Our drive can also be used in robotics, automotive, wind turbines, and prosthetics. We are a group of multidisciplinary co-founders, and together with our partners, we truly believe in our technology. We started this journey because we wanted to solve one problem: make big and bulky prosthetics more accessible for women and children. But along the way, we realized the potential of our technology, and that's why we entered robotics, where we got our first customer, who stated during contract negotiations, "So, how much will it cost to make 1 million of these?" From there on, we knew we had something special in our hands. And with the aid of some seed investment, we went after a new market, where we found our new customer in wind turbines, who were so pleased with our claims that they even stated that if we can hit those numbers, they will buy the whole company champagne. Well, we're only 5 at the moment, so it's not that much champagne, but I hope you get the point. But our dreams are to go even further. The next is to go into electric vehicles. So, Tesla, if you're out there, we heard you're having problems with your drives. Come give us a call and let's see if we can sort this out. And finally, when this is done, we will go into aeronautics, where we can drastically reduce the cost of travel. Do you see, ladies and gentlemen, if we succeed, we will be the first major breakthrough technology in this field within the past 50 years. And our invention, could be applied to a multitude of products with a complete market size of over $70 billion. And we want to control a large portion of it. And that is why IM Systems, just like Archimedes, will be making the impossible possible. Thank you.
Yeah, so I start with the first question. Definitely weight is a crucial element in aerospace, but what about safety? You know that the other first requirement. What can you tell us about contamination of contaminants, or how your system resists to those safety issues?
Thanks. I'm Jack Schorsch, the CEO, and also the technical founder of the company, so I'll take that question. In response to contamination, because of our design, it's very robust against particular material contamination. There's a lot of flexibility in the system, so as you add material into it, it is able to actually absorb those materials without damaging the mechanical structure of the drive. Of course, it has to be maintained at that point, but it's very robust against contamination.
Congratulations. So you're only 5 at the moment. If you're getting bigger and bigger contracts, do you plan to license your technology to other people or to turn yourself into a real manufacturing powerhouse?
That's a great question. And it speaks to the strategic direction of our company. And it's interesting because we're here in aerospace, but that's actually one of the most difficult markets to enter. And so we're starting in robotics where the barrier to entry is a little bit lower. The requirements, those reliability requirements, are not so high. But we are very interested in licensing our technology, especially into the challenging markets, let's say power generation and aerospace, for just those reasons.
I want to add on to that. So we're using this strategy at the moment. So for the robotics, our first customer, we're making the products in-house. For the wind turbines, we're going to do a licensing model.
The technology looks really great, and it's really surprising that there is no other competitor in this field. So your technology is patented, but is there any alternative with a friction drive which could do the job? Or what makes your company different?
Okay, so that's my background. I've been doing research in this field for about 10 years now, and was actually participating in a project run by DARPA almost 10 years ago, and we spent the project itself spent about $30 million looking at alternatives to this kind of technology, and we actually weren't able to solve the problem at that time. I kept this problem turning over and had the breakthrough about 3 years ago now that really allowed us to combine two fundamental technologies. We use compound gear technology combined with this friction drive. It doesn't work one or the other. You have to bring them together, and you have to use our patented techniques to do it. Thank you.